Bien, buenas tardes, bienvenidos a todas y todos. Soy Enrique de Alba, tengo el honor de presentar al doctor Mark Reichardt. Él tiene la responsabilidad de todas las operaciones del OGC, supervisando la elaboración y la promoción de las normas de OpenGIS y trabajando para garantizar que los programas del OGC impulsen a sus miembros hacia el éxito. Trabaja con otras organizaciones desarrolladoras de normas y asociaciones profesionales para establecer acuerdos de alianza con el fin de asegurar que las normas OGC y otras más funcionen fluidamente en conjunto. Esta coordinación es muy importante, por ejemplo, para sustentar normas que permiten la completa integración de la información geoespacial con datos de sensor en tiempo real y el modelado de información para la construcción que se utiliza en arquitectura, ingeniería, construcción y gestión del ciclo de vida de las construcciones y otras infraestructuras físicas. Se unió al OGC en noviembre de 2000 como director de mercadeo y programas del sector público. Llegó a ser el presidente del OGC y miembro de la Junta Directiva en septiembre de 2004 y fue nombrado presidente y director ejecutivo en enero de 2008. Antes de entrar al OGC, estuvo trabajando en los programas de producción y modernización de la tecnología para el gobierno estadounidense. A mediados de los 90 fue miembro del equipo para el Producto Integrado de la Información Geoespacial del Departamento de la Defensa, formado para ayudar a la transición de la misión cartográfica del Departamento de la Defensa a un paradigma basado en geoinformación más flexible y respondedora. Bajo su liderazgo, el equipo validó la capacidad del hardware y del software comerciales disponibles para la venta de satisfacer muchos de los requisitos funcionales del Departamento de Defensa para las operaciones de la producción geoespacial. En 1998 aceptó el encargo de la Asociación Nacional para la Reinvención del Gobierno del vicepresidente Gore de administrar un programa para ilustrar cómo el uso de la información geoespacial y sus tecnologías podría mejorar la coordinación de los gobiernos local a federal. A inicios de 1999 fue seleccionado para establecer y dirigir un programa sobre una infraestructura internacional de datos espaciales, IDE, para el Comité Federal de Datos Geográficos. En este puesto, ayudó a establecer prácticas del IDE nacionales y regionales compatibles mundialmente en África, América del Sur, Europa y el Caribe. Fue fundamental en el establecimiento de los acuerdos de colaboración del IDE entre naciones. Pertenece a la Junta Directiva de la Asociación de la Infraestructura Global de Datos Espaciales, GSDI, y a la Junta Directiva del Building Smart Alliance.
Good afternoon. Thank you for that wonderful introduction. And I'm very grateful to INECE and the United Nations for inviting me to speak this afternoon. I understand that speaking right after lunch is not the best time, but I hope you will enjoy the presentation. I don't plan on taking all 50 minutes, so I'm hoping that I can coax you into asking a few questions. So my briefing today, my presentation today is about the principles of interoperability. That's a big word, but simply put, it's the ability of diverse systems and organizations to work together, to interoperate. And coming from the standards community, I always think of this as a standards issue, a technical issue, an information issue. But in reality, it's much more than that. It's a policy issue, it's a legal issue, it's an institutional issue. And these are by far the hardest parts of interoperability. I think many of the technical issues, as you can tell from our industry partners, are solvable. Many of our information interoperability issues are indeed solvable through standards and best practices. But those institutional and legal and policy issues sometimes can be extremely difficult. But it's worth it. Interoperability will save time, will save effort, will save money, and what I've witnessed in my 13 years working in standards, it'll save lives. And I think that's the most gratifying thing to actually see, is when all of this works perfectly to create those kinds of wonderful outcomes. We all are subject to a number of things that are changing faster than we can maintain. Coastal issues, the quality of our water. We've got pandemics that rise up, and we have to find out where they started, how they progress, and how we stop them. And then more and more, the issues of water, either not enough or too much. And I don't know if you have noticed, but I have, that the 100-year storms are coming much more frequently now as our world changes and adapts to a different climatic reality. And this concerns me only because, as many of you, I have children, and we have to leave this place better for our children and their children. What really brings it home, though, are some examples. I brought this one out of a conference, the Global Spatial Data Infrastructure Conference a few years ago. Where is this? This is the Netherlands. And for those of you who are good geographers, most of the Netherlands is underwater. It's basically below sea level. And through a very intricate and complex network of water measures and dikes and other preventative measures, they manage to stay dry. The real power of interoperability and the work that we do comes when you look at when we don't have this information. This would be the Netherlands if they did not act. And so I ask you to consider, with 1 foot of ocean rise in the next 20, 30, 40 years, any additional increase in the surface of the ocean, what is the impact for countries like this? What is the impact for the coastal areas where most of our populations reside? We're going to need every bit of information, every bit of shared intellect and solutions to deal with these problems. And if you could advance one slide, it's not working for me here. There we go. And so the other area I think that's important for us to keep an eye on is the continuing urban development and the balance that we need to achieve in terms of use of resources and the way that we contribute to the carbon budget and things of that nature. So urban sustainability, I think, is a big issue, and this environment, geospatial, is starting to make a big impact on how that happens, and most of this occurs due to interoperability. So it's a big word. Let me tell you what I don't think interoperability is. You know you don't have interoperability when things take a long time to integrate. You want to add new software and you have to custom development. When you pay much more money than you wanted to integrate those technologies. You have difficulty adding new capabilities when there's an emergency. You can't plug them in because of a lack of interoperability. Duplication of effort and missed opportunities. All of these things, I think, are a result of not having interoperability. Now, I'm going to appeal to the engineers out in the audience. Does anybody know what that is? How many of you were alive in 1978? How many of you were alive in 1978? Okay. This was my first realization of the perils of lack of interoperability. Does anybody know what this is? Do you remember Apollo 13? So one of the Apollo missions to the moon, Apollo 13, took off, and on the way to the moon, The service module, which has all of the life support and power for the command module where the astronauts reside, exploded. And the astronauts had to move into the lunar lander, which is a separate but connected spacecraft. And so we thought that lives would be saved. They would just make the trip around the moon and come home. That device is called a carbon dioxide scrubber. The 3 astronauts went into the lunar module. It was built for 2 astronauts. And after a period of 24 hours, the carbon dioxide levels became toxic. And so what the astronauts had to do was to fit a square peg in a round hole. Believe it or not, the carbon dioxide scrubber in the lunar module is round. The one in the command module is square. So they put together with cardboard, manual covers, duct tape, moon rock bags, and spacesuit vacuum hoses, a solution that ultimately saved their lives until they were able to come back to Earth. Because the contractors and the government couldn't imagine that the lunar module would be a life raft. This, to me, is a fundamental issue, I think. We have to plan for interoperability in everything that we do. So that's the solution. That's actually on board the lunar module, and you can see the spacesuit hoses and everything else helping to get that carbon dioxide scrubber to work. In OGC, we produced a number of standards. I'm not going to brief you on this because that will put you to sleep. But they're important only because they allow geospatial information, images, features, coverages, and other types of geospatial information to come together so you can bring it together, integrate it, and act on it, make a decision. And it's seamless. Hopefully you never know that those standards are working to make that happen. In addition, there are standards that we have developed that allow you to take advantage of all the sensors that are out there, the millions and millions of sensors that can augment your understanding of the world and bring that into a location context. So this is the work of industry, government, and academia. And I would also say it's a work in partnership with the ISO organization, the Technical Committee 211, which is represented here by Olaf Ostason. We work together to produce these standards to allow interoperability to occur. In order for it to work, we need to understand how all these piece parts fit together. And this is one example of a document by the Global Spatial Data Infrastructure Group that helps us understand how we put these standards together and how we implement services and data content and data models at the foundation level to make all of this work. And this is a page from the GSDI cookbook. And if you haven't read it, I would urge you to take a look at it. It's a really interesting document because it provides not only information about the standards and how they're used, but it provides use cases and context in which they're used. And of course, if you read in there, you'll see that they've identified a core set of standards. And I think this is one of the big interoperability agreements that needs to occur, is that organizations need to agree on a common set of standards. And this document will help articulate that. So we actually have made great progress over the last few decades. We have a number of spatial data infrastructures around the world. I just use this as one example. Of course, we have them here in Mexico, Chile, other areas of Latin and South America, and as well as other continents. But spatial data infrastructures are actually starting to provide an incredible amount of value in allowing information to be made available publicly to users to enhance decision making. This example, as I mentioned, is Canada. And I'm astounded every day I look at what they do, from forestry to watching the progression of the political voting and other types of activities in Canada. An indispensable infrastructure. Also, we're seeing an explosion of web services. This is just a small sample of some of the web services that are out there today. Everything from access to information in Catalonia, Spain, using web services and OGC ISO standards, to aviation information served up for use by pilots and other planners, and other examples including urban models, the ability to look at an urban environment in 3D and understand a lot about the objects in that model and what that might do for us as a society. All of this is enabled through policy, and this is the other fundamental principle that I think is important for interoperability. This is a cross-section of policy documents from the defense and intelligence community to INSPIRE in Europe, to spatial data infrastructures around the world, and also localities like Abu Dhabi, New Delhi, where in their procurements they're specifying specific standards that need to be delivered in whatever products come their way in a tender. All of this is helping to align the community toward greater levels of interoperability for the benefit now and in the future. I just found the other month a cookbook from New Zealand, which is really nice because this one not only talks about the technical aspects of interoperability and standards, but it provides a number of different use cases for those who wish to be part of a spatial data infrastructure, provide information and assets to that spatial data infrastructure, as well as how others can use that resource to benefit decision making. And it also covers other issues such as service level agreements between agencies and licensing. And that's available on the web. So one of the toughest things that we've had to address, and it's actually now become much easier, is how do we get agreements on interoperability within a community? Our founder, David Schell, the gentleman who created OGC back in 1993, he made a statement that rings true to me today. He said that interoperability seems to be about the integration of information, but what it's really about is the coordination of organizational behavior. And so on that note, I want to talk about water resources. There are tens, if not hundreds of thousands of water observations around the world. Fixed sensors, sensors that are on the move in the ocean, subsurface and surface observations. And unfortunately, all of these observations are varied, and there's really not a comfortable or easy way to integrate them. Every country has these types of data. I'm sure that many of you are accessing that information here. But what's really needed is a way to bring all this information together so you can look at a region or a locality or globally different aspects of water resource availability. And so what we really need is global water data integration. And the objective is to get to this idea where all those different observations can be accessed, integrated, and applied in your decisions so that you can start looking at these more complex issues. About, several years ago, OGC we were happy to receive a number of individuals from the hydrologic community. And we started a process to create a water markup language that would help integrate all these observations. We created a working group to bring together industry, government, academia to have a dialogue. We reached out to the World Meteorological Organization, and they were happy to come in and not only participate, but help chair the working group. More on that in a second. And then we had a series of technical meetings, experiments and prototyping that led toward the adoption of what's called Water ML 2.0. That's now an adopted standard. It's been adopted in the policies of a number of countries, and it's now being considered for incorporation as part of the WMO policy environment. So here's where we had an ability to bring together a group of like-minded organizations and have them work on creating a single approach in standards and interoperability to better address water observations, which, as you know, is a critical issue right now in many areas of the world. And again, it was truly a combination of government, industry, and research organizations and academic collectives. I think much more of that's happening now in our process. We're finding that that seems to be the way to promote interoperability effectively. This is an example of the Office of Technology, Science and Technology Policy in the United States. WaterML is actually called out as an underpinning standard for Earth observation strategy. And you see this happening in other countries now as they become aware of and adopt these standards. We'll talk a little bit about smart cities. So we have a standard called City GML. GML is short for Geography Markup Language. And what this allows us to do is to create a very detailed three-dimensional model of cities and to be able to attach to any object in that model lots of information that might be available locally or out on the web. So it's a way to organize all of this information into a logical model. And we're finding a great explosion of applications from urban planning to emergency services to line-of-sight telecommunications placement, logistics, and even retail. So all of this is happening because city managers and others can see the city as a coherent model. I want to point out that the model is not limited. You can actually see the buildings on the outside, and if the information is available, you can do indoor navigation as well. You can see the interior of the building. Well, in Germany, in Berlin in particular, there is a group called the Berlin Location Center, and they've developed a complete urban model of Berlin. And they use it, amongst other things, to promote business coming into Berlin. They use the model to entice new companies to come in. They use it for real estate. And they also use it for things like carbon offset. So here's an example in Germany where they computed the ability of rooftops to provide solar energy. They also computed the carbon reduction that would result if somebody implemented those solar panels. And what they do is they use this as a first step for German citizens to find out if their roof is a good candidate, and then they follow on with a process to install the solar panels. What's interesting here is that if you look at the percentage of renewable resources that Germany has been exploiting over the years, it keeps growing. And as it turns out, solar, wind, and other types of alternative energies are growing in a large part because they're using geospatial technologies and this interoperability to bring information together to inform their decisions. And interestingly enough, the problem they have now is that there are so many people plugging into the grid with their solar panels that the grid is starting to become somewhat unstable. And so, the grid was built for big power generation sources. So, but I think this is a real good story of how our technologies and interoperability are helping to promote carbon reduction, alternative resources, and energy. So we've talked about the spatial data infrastructure. What I wanted to talk about is how we move from spatial data infrastructure to what we call the geospatial web or the semantic web. Carl Reed is our Chief Technology Officer at OGC, and he said once that the geospatial web is about the complete integration and use of location at all levels of the internet and the web. And in that context, we're talking about bringing in billions of sensors. How do we get our arms around those sensors and provide that information in a location and time context? How do we address increasingly complex observing systems? And I believe Barb Ryan is here from the group on Earth observations this week. She heads up an effort to help build a common open architecture to get better access to all of these Earth observation assets around the world. So how do we bring all that in? I think interoperability and standards and policy agreements are the key. Additionally, we're seeing a big increase in the use of the cloud and predictive analytics. And so our obligation from the standards community is to create greater interoperability for processing so we can do short-term forecasting, long-term forecasting, and other complex processes that we may have taken days or weeks to do can be done on the cloud now in a shorter amount of time. So I'm now going to talk a little bit about market and technology trends and what we're doing as a community to address these. This morning, Vanessa Lawrence talked about the Future Trends study that was released by the organization several months ago. That is a very, very good document, and many of the things that we're doing in the OGC parallel these trends and predictions that have been put forth in that document. So I just wanted to acknowledge that I think that effort was very well done, and it's becoming a roadmap of sorts for the community to understand how we can leverage technology change to our benefit. So let's talk about location data quality. I looked at a few excerpts from the media, and the first one was interesting, that roughly half of all the venue data on Facebook, Foursquare, and other sites like that is not accurate. Another one says that there's an effort of inferring location. People are on the social web and they probably have an expectation that data is accurate, and in many cases it's not. Now that may not be harmful, but it depends, I guess, on what you're using the information for, how important that is. But what's obvious here is that location is increasingly coming into the conversation as an issue. The last quote here is that it's important for decision makers to understand the fitness for use of that data before they make a decision. How many of you know the quality of the data when you make a decision? Now, add to that 5 or 6 or 7 different sources coming together across the web, fused into a view. What's the accuracy or the uncertainty of that information? I think this is one of our next challenges, is how do we deal with quality? How do we deal with uncertainty so we can make better decisions? The UN GGIM Committee of Experts recently released a report of the Secretariat that talked about quality as a key element. It went so far as to say that an international framework is needed to establish a language of quality. So I think this is probably our next challenge for interoperability and for standards, is how do we work to provide better understanding of uncertainty, better understanding of quality, so the decision maker is better informed. What we're doing in the OGC is we have a working group that's devoted to this. They've done a survey of over 1,000 professionals. We're acting on that data now. But more importantly, they're working in some areas to actually address how we can deal with uncertainty. There's a markup language out there that actually lets us do that. And so we're experimenting right now on how to bring in different data sources and how we can assign them with a level of uncertainty so the decision maker is more informed. So I talked about sensors, and that's been mentioned quite a bit here at the conference on day one, but I think this is a humbling area. The sensors are growing faster than people, and pretty soon the web is going to be mostly a communication between devices and machines and less so people. And some quotes here, I think one was mentioned this morning, up to 50 billion devices will be on the web accessible by 2020. The one I found most interesting is from General Electric, where they say that the market is probably 10 to 15 trillion to the global economy. So this is a big, big topic. The other thing that's interesting is all the devices now that you as an individual can purchase that can be connected directly to the web. And I can't tell you much about these, but my staff are actually implementing these. Everything from temperature sensors to soil moisture sensors, all connected to the internet. It's a wonderful thing. There's a problem. And the problem is my clicker does not work. So what we want to be able to do is to deal with large-scale opportunistic sensing. How many of you have one of these? Did you know that several universities have already demonstrated that they can, based on hundreds or thousands of these devices in a region, they can predict seismic activity? They're already down to about a 4.0, and they think they can go lower. The point is, they're using these things are fitted with all kinds of sensors, pressure, altimeters, shake sensors, and Berkeley and a few other universities have demonstrated where mobile phones that are on can be accessed, and if you group them, they can actually give you a little bit of an advance notice about an earthquake. And a precious few seconds is pretty important for people and equipment. The other thing are pressure sensors. They're getting really cheap. Oxygen sensors, very cheap. The cheaper they get, the more interesting the problem becomes, right? Because they're going to be pervasive, and there's so much opportunity to get information from these. The problem is, in most cases, when you buy a sensor or a device, you get their architecture. That's not a bad thing, but the problem is that you have to customize the way that you communicate with these devices. So what we're doing in the consortium is working on a sensor web for IoT standard that essentially allows you to treat different sensors in the Internet of Things as a mashup. And that standard should be available by the end of this year. Now, for those of you who aren't technical, I don't blame you if you find this a little dry. But what's really interesting about this is think about harnessing, if you're in meteorology, think about harnessing all those sensors, those incidental sensors that are out there, and what that could do to improve your forecasting. That's pretty amazing stuff, and I think it's coming quickly. Could you advance to the next slide? Thank you. Let me talk about mobile. One of the forecasts says that by 2020, an individual mobile phone will be processing 1 gigabyte a day on average. That's a lot of information. So I thought about taking the phones away from my son and my daughter, but I knew they wouldn't like that. But the reality is that the information flow is increasing faster and faster, and we need to get our arms around that. Some other things too is that, and I'm sure it's true in Latin America as well as other places around the world, is that the PC is pretty much dead. In Africa, it's mobile only. The mobile device does everything, including currency transactions. And so that is the platform for the masses, and we need to adapt to that platform in terms of interoperability. The chart on the right, that came from an analyst who looked at the increase of mobile usage in India starting back in around 2008. And just a short while ago, mobile processing outpaced PCs. So it's happening. We're moving to a mobile platform, and the reality is we need to move all of that intellect, all of that interoperability into the mobile environment seamlessly. So one of the things we did, this is fairly simple, is we created something called GeoSMS. Has anybody heard of that? Has anybody sent a text message ever? Okay. All right, good. Just want to make sure you're still with me after lunch. What we found in talking with a number of our members, particularly those who respond to regional disasters, is that when the wireless communication networks fail, they typically fail for voice. They do not fail completely for text. And when they begin to get messaging, they have two fundamental problems. One is, what is the emergency? And the second one, where are they? What this little standard does, it's very simple. It puts a latitude and longitude at the front of the message. So when somebody types a message and sends it to you, if you open it up on your smartphone, it just drops a pin down on your map application and opens up the message. It's that simple, but it's fundamental in terms of its impact to the community. And so I think we're going to see more and more of these small scale but very, very powerful standards come forward in the mobile environment as we go forward. Now, some of you may be familiar with some of the platforms, the open source platforms that are available for coordinating global response to regional disasters, like Ushahidi or Sahana. These are wonderful platforms. GeoSMS now is a component of both of these. So when they start operations, they can receive these location tag messages and hopefully be able to act a lot more quickly than if they hadn't had that information. And we're starting to see commercial interest in this standard as well. One of the last few topics I want to talk about is the indoor challenge. So all of you navigate, I'm sure, outside with no problem at all. The problem is about 90% of our time is indoors. And so there's a lot of effort right now going on to address the indoor problem, indoor navigation, indoor location, indoor positioning. There are many, many, many different location rendering technologies that are available, but very few standards to deal with that problem in a location context. There are companies that are producing indoor maps for shopping centers and retail and other activities. And if you find Ed Parsons here from Google, he'll talk to you about an Android app that's doing something similar with apparently very good accuracy inside space, inside the building. But one of the observations made in The Economist recently caught my eye. It said that indoor infighting means that technology companies are duplicating their efforts at great expense. This is a standards and interoperability issue. So we're working right now with the community to try to understand how we can create open standards that let us navigate, position, and work inside an indoor space using all of those different technologies. And this graphic here just shows it very simply that it's a standard called Indoor GML. It works with our city GML, those urban models I showed you. And it does two things. It shows the interior space of the building, and it defines the sensor area of all the sensors in the building. And with those two things, you can begin to do some very precise navigation inside the space. And I probably don't need to talk too much about why this is important. Everything from handicapped, impaired individuals who don't have a sense of sight might need help navigating to emergencies and even retail. So we don't do this in isolation. By far, we do not do this in isolation. And I wanted to spend just a couple of minutes talking about the broader standards community and what they're doing with interoperability. When it comes to geospatial, we work hand in hand with ISO Technical Committee 211. It's a great marriage. Many organizations, particularly governments, require ISO standards. ISO has developed a number of foundational standards that we must use when we develop ours. And in fact, many of our standards are available as ISO standards, and that's deliberate. We work together to make sure that we don't duplicate effort. We also work with regional standards groups like CEN in Europe. And we also work with organizations like GSDI, the Global Spatial Data Infrastructure. But you know, the really interesting stuff is happening elsewhere in the IT infrastructure. So you'll find location standards from OGC on your mobile phone, and standards by the IETF, or World Wide Web Consortium, or OASIS. We work with those standards groups so when they reference location that it's consistent, that they're using our standards in a way where it's consistent for the user. And I do want to acknowledge all the great work that we've been doing with Olaf's committee. It's just been great. The other area that I think is fundamental for us is the Internet of Things. We work with the International Telecommunications Union to help drive the reality, the development of the concepts and the implementation of the Internet of Things. We're not a leader in this space, but we do provide the location and sensor and other types of inputs, and this is really important. So don't think of OGC as just a location standards group. Think of us as about a patron in the community. It's trying to help keep a consistent reference of location throughout the standards stack. So in closing, it's obvious to me from the time I was a teenager following Apollo 13, and as a kid you can imagine the stress of knowing that there's 3 men in space and they might not come back. That was really scary. And thank goodness to NASA that they figured it out, but what if they had the same canister? It would have just been, you know, plug it in and no problem. If duct tape was not on that ship, they would have died. That's how close it was. So we need to plan interoperability in everything that we do. Fundamentally, it needs to be standards for technology and information, but more importantly, it needs to be policy. We need to embrace technology change, find a way to leverage it, and not be scared of it. It's okay to change. We must have a better understanding of quality, uncertainty, and fitness for use. I think this is one of the fundamental challenges that we as a community have. And good standards and good policy will help make that happen. And we're proud to be a partner with ISO TC211 and others in helping to create that level of interoperability and standards. And I want to thank all of you in the community who are implementing for the feedback and input that you've given us and the criticisms. Sometimes we don't get it right. And so I would ask that you make sure that when you see a standard, you use it, and you have a problem with it, do not be silent. Register your complaint, because the more information we get about standards you need or how the standards aren't working, the faster we can make them better. And with that, I'm going to give it back to the chairman, and thank you, and thank all of you for time. I hope this was enjoyable, and maybe I'll answer a few questions if you have them. Thank you.
Bien, muchas gracias al doctor Reichardt. Tenemos tiempo y él está dispuesto a contestar preguntas. Entonces, si alguien quisiera.
Nothing?
Aquí, here. They're bringing one.
So when we start talking about billions of people not only contributing to the data but also using the data, one thing that I'm sure going to keep you probably and me up at night is how do you create multi-year, consistent, reliable databases? What is OGC doing to make that happen?
I'm sorry, could you repeat the question?
So when you have these multiple data sets that are coming through, what is OGC doing so that we can create multi-year, consistent, and reliable geospatial databases?
Oh, that's an interesting question. The database issue is interesting. I mean, we create the interoperability for the information to flow and for it to be maintained. But I would believe that there are some significant challenges for archival and other methodologies that we would need to address. In fact, we have a data archive working group that's looking at long-term preservation. One of the things I saw recently from, it was one of the national research institutes, is the line of increased digital output overwhelming the ability to store it, yottabytes, things of that nature. And so they're looking at different techniques about how they can, say, store imagery, but only store the pixels that haven't changed, to begin, you know, compacting and looking for different ways to manage that information. I think that's basically a response to your question, unless I misunderstood it, but I think there's some significant challenges there.
I'm Mark Fraser-Taylor. You mentioned all the kinds of stuff that OGC is doing, but I wonder if you could say a few more words about how a community like this one could become more actively involved with OGC. OGC is not only a top-down organization, far from it. It involves everybody at all levels, and if people wish to contribute to this process, how do they do it?
Well, there are a whole bunch of different ways. Thank you for the question. And I didn't intend for my presentation to be about OGC, but more broadly about the geospatial standards. But the public can play in our process by simply giving us information about what works, what doesn't. The ability to interact with our process and our working groups is largely open. So somebody who's interested in meteorology and how to better implement best practices can participate in our working groups without restriction, either in person or by virtual means. We also have a membership set of categories where different levels of membership you can participate directly in the organization. And the benefit of that is it's largely the networking, the ability to actually speak directly to industry, government, academia, and others in a way where you're sharing ideas and not trying to sell something or purchase something. You're actually trying to just to get an agreement on a concept. The other thing that's really interesting, and it may be more direct to your question, is that we do a lot of active prototyping. When we develop a standard, we like to go into the community before the standard is adopted and rehearse how that standard is going to behave in a real operational setting. So we do pilots and experiments, and we reach out to communities around the world to help us with that, to make it real, so that we know when the standard is finally adopted that we have a validation that it works. And there are a number of other ways that organizations can participate in the OGC. We also have something called the Gov Future program for those of you who are in government at the subnational to national levels. It's all about getting government together from different walks of life, different regions, to compare notes. And we do it largely through webinars and other types of virtual dialogue because we know travel is very expensive. But that's an opportunity for someone in government to listen to how somebody else has solved a problem, to see if it applies to them, and for you to do the same with communities around the world. And so if you're interested, I can provide you with more information about what we call our Gov Future program.
Buenas tardes. En la parte de desastres de ahora con el huracán Katrina, parte de lo que se dio un problema muy grande fue la parte de las bases de datos de todas pues ahora sí del comité de desastres para atenderlo. ¿Nos podría platicar algo al respecto? ¿Qué hicieron para la interoperabilidad de sus datos? Los datos que se usaron los diferentes, la Guardia Costera, los Navy, todos para atender las emergencias.
So I'll try to answer the question in general because I'm not familiar deeply with how the Katrina response actually worked. I know that many of the official data stores were online and available, but when the communications went down, that became problematic. And we have an effort going on right now, several efforts. One is called geosynchronization. It's a big word, and I'm not sure our translators will do a good job with it. But geosynchronization is all about allowing an individual or an organization to acquire data from all types of different sources and then be able to go offline. And that may be because they want to, perhaps a military operation, or more than likely it's because they have to, because the communications have gone down. And the interesting thing about web services is they work as well on a mobile device or a laptop as they do on the internet. So what geosynchronization allows us to do is to work offline, collect information, and when the networks come back up, you become a node back to the source. Another thing that we're working on right now is called GeoPackage. And you'll find that on our website. It's called GeoPackage, and it's very similar, but it's for mobile devices. It's how do you take the application software and the data and load it up very quickly on a mobile device so it can act either connected or disconnected. So a lot of what we learned in those types of scenarios, emergency response, military, where the communications are broken in the theater, really helped us understand why these standards need to be advanced. And I hope that answered your question.
Bien, pues muchísimas gracias al doctor Reichardt y le voy a entregar un reconocimiento por su participación.